Thank you very much. Alrighty. So this is my first community summit. Although I've a little bit more today, we're going to be talking about building AI agents using AWS Strands Agents SDK. But before we do, let me do a quick intro of myself. So who am I? Yep, as I said, I'm Aaron Walker. I've been involved in AWS communities for a very, very long time, since going back to sort of 2010 timeframes, kind of when I was sort of first got involved in AWS meetups in Melbourne, Australia. As you can tell from my accent, probably that I'm expat Australian, now living in Germany for the last 7 years. I also run the AWS user group in Berlin. I'm in part of various AWS community programs, as well as on the partner side, AWS Ambassador. I recently joined the AWS Community Builders program this year, which was, it's a great program and I recommend it to everyone, just to get some more insights on things going on at AWS, and being part of a sort of global AWS community is pretty awesome. To see all the people from all over the world, what they're doing and how they're doing things. So a bit of a plug for the Community Builders program. So, so we're here to talk about AI agents, but why are we suddenly so interested? This year seems to be the explosion of this term, an AI agent. To me, whenever I think of AI agents, I'm old enough to remember Microsoft Clippy, and it popping up saying, oh, I see you're trying to write, these days it would be some code. How about I try and break it for you, right? That's kind of like to me that was like, whenever I think of an AI agent, that was kind of like pops into my head. I think of Clippy sitting off to the side going and doing, and providing absolutely no help whatsoever. And also everyone looking for the button to turn it off, right? So that's to me, that's something, that sort of has this history of okay, so what are they? What do they do, right? So really in sort of, when we look at AI agents today, what we're really looking for is things that can help us automate things, help us make decisions, but the most important thing when it comes to making decisions is the context, right? So an agent without context is not very useful. It's going to give you a very generic answer, right? It's about how do we build agents and provide it the right context at the right time, right? Not just try and provide it all the context all the time, right? So it's about focusing into that. It's then also about, agents are also about taking action, right? So it's not just about, providing some insight. So it's not just a chatbot that we're just talking to and we're getting back some generic answers, or maybe we're even getting back, focused answers. But it's about the ability for the agent to take action, right? It's the ability for us to do things. So it's how do we integrate that with systems and tools? How do we make the agent aware of those systems and tools and give it the insight to say, when is it appropriate to use a particular tool and when it's not? And also we want to do this because we're lazy, right? We don't want to do work. We want machines to do work. So this is kind of the next phase of how do we be more lazy, right? But constructively lazy, not just lazy for lazy's sake. So what about the challenges in building agents? So one of the biggest challenges, in building it is well, how do we make sure that what we're doing is secure, right? A lot of us maybe are working with coding assistants, and we give the coding assistant our GitHub credentials, right? We're giving a certain level of trust, right? So you have to build that trust. The AI agents have to provide that trust, and one of the key things around doing that is making sure that there's auditability, right? Why did the AI agent decide to do what it did, right? There has to be some kind of decision an audit trail around that, right? So that we can diagnose if things go wrong, why did it go wrong? Was it we didn't provide the right information? Did we not provide enough context? And the AI agent decided to make something up. So looking at how we can kind of manage that and deal with that. So thinking back that, right? Also around how do we, the idea of an AI agent is that we don't want to necessarily build an agent that does everything. Like one agent. We don't want one agent, right? We don't want this one big monolithic agent that can do everything. So it's about breaking the problem down into smaller pieces, like using just sort of traditional architectural principles, avoiding large monoliths, and avoiding the old black box problem, right? But also then, how do we take our agent to production, right? How do we ensure we can scale it? There's a classic example of an AI agent, like from AWS, that even they couldn't handle and deal with the scalability problems, and that's around Kiro, right? So I don't know, everyone's heard of Kiro. It was launched, and they allowed everyone to sign up to it, and everyone did. It did at the time, and then they weren't able to deal with that load, right? And so then they had to kind of put it behind a wait list, right? So that's a classic example. Even AWS weren't able to kind of foresee the scaling challenges that they would face with that. And then, okay, we've got AI agents, we've got them running, and, how do we handle it from an operations and management and monitoring standpoint, right? Like, how do we make sure they're doing what they're supposed to be doing? So making sure that there's observability built in, that we've got monitoring and around the operational side of that. So let's talk about the interconnectivity, right? So this is a buzzword, like who here's heard of Model Context Protocol, MCP? Most people in the room, cool. So MCP is an open standard created by Anthropic. It's got a huge buzz behind it. Basically, it provides a universal bridge for agents to go and request externally additional context, right? Additional information. Has the concept of tools and resources. So you can have a MCP client that goes and says, give me some additional information about XYZ, and then or execute a tool, just to go and get additional information. Right? And so then an agent can use that, right, to go and do that. So it provides essentially live access to data that the model didn't have before, right? So the model that you're using wasn't trained with that data. This is a standard way to go and get that. It also sort of gives agents additional capabilities that they didn't have. So let's talk about another sort of way agents can talk to each other. And this is what I find, to me, MCP is great, and it's a great tool, and it's there's a lot of like hype and buzz behind it. But there's another standard, which is the agent-to-agent protocol. This is a protocol that was donated by Google earlier this year to the Linux Foundation, and it really is. I think it's not. It doesn't replace MCP, it's different, right? So it's a way for agents to communicate with each other, right? It's a way that you can use agents to discover other agents, and then you can use that to coordinate solving large complex tasks, right? It has sort of the concept of sort of built-in secure communication between the agents as part of the specification, whereas with MCP, sort of authentication is kind of like an add-on. It's about being able to break down a problem and then distribute that, potentially among different agents within a network. Potentially even agents that you might have, connected an agent to talk to another agent, but you don't necessarily know that might actually reach out to other agents to go and solve its problem, right? The thing that you've asked it to do. It might break that down and then communicate with other agents. It's about how do I distribute intelligence. So one of the things as you start to go and build more AI agents, what you realize is that you want to build them in a way that they're very focused, right? They have a very focused, narrow scope, right? They help you solve one problem. And there are many advantages to doing that, right? Because often you'll find now, you'll build an agent and the large language model that you use behind it, it might be extremely capable, right? It might be a newer reasoning thinking model, but you might not need that. If you scope and provide the right context and the right information and design the sort of prompt in the right way, you can probably often get away with less capable models, right? Usually that means that equates to being cheaper and potentially faster, because you're not having to provide that additional sort of reasoning and thinking capabilities. You're asking it to do a specific problem, you've narrowed it, you've provided it all of the right context. And so it can very accurately give you nice, repeatable answers, right? That's one of the ways to kind of control that, is to create very narrow scopes and tight context for agents when you build them to do that. All right, so the part of the talk is here to sort of introduce Strands. So Strands Agents was basically, it started its life as an internal tool within AWS as they were building out various AI agent systems in their tool, primarily around tools, things like Amazon Q. And they realized that, you know, there's a lot of different tools out there for doing that at a time, but all of them, you know, involved potentially, you know, complex APIs, wiring up lots of different pieces of technology. And so they decided to go back to the kind of drawing board and rethink the problem around, you know, how would I ideally want to build an agent? And so they created this SDK, which they then open sourced earlier this year. And basically it provides a really kind of, I guess, a toolbox for you to go and build your agent, right? It's very modular, stateless, and it provides kind of the built-in things that you're kind of looking for when you want to build an agent, like auditability, traceability, metrics. And obviously being, you know, an AWS SDK, it's kind of built for, you know, deploying it in a cloud-native environment. And actually, it was kind of earlier, like in the middle of this year, and I'll talk a bit about that. You know, there's basically out of that comes a platform referred to as Agent Bedrock Core, which I'll talk about in a minute. But let's kind of look quickly, like, at what it takes to build an agent using Strands, and that's literally it, right? That is an agent, right? It doesn't do very much. It doesn't have any you know, it doesn't have any memory or any state, but that's as much code as it takes, right? So what's actually happening here is basically I'm creating an agent, the default one, and there are defaults built into Strands. So for example, the model that it's going to use. And so this, by default, it depends on what region. It's likely to be Claude. It's likely to be Claude 3.7 or 4, depending on if it's, you know, what region you're doing it in, the model. So there's a whole bunch of kind of built-in, like it's this, you know, convention over configuration, right? It's got a convention, I didn't pass it anything. So there's a whole bunch of defaults that it's going to take, and that's actually going to execute. And we'll see that later in a demo when I do a attempt to do a live demo, which is always fun. With AI agents, they always usually do the wrong thing that I ask it to do, but that's what we're here for. So what's actually happening when I execute that agent, right? So Strands architecture builds out this concept of the agentic loop, right? So the agentic loop is about, we can kind of start there on the left, and we've got a prompt that we invoke the agent with, and that was what we saw in this one. That's the prompt I gave it. Tell me the best thing about AWS communities. And so that gives that to the agent. The agent then takes that and then invokes the large language model with that prompt, that initial prompt. And then the model does its thing and it gets back a response. It'll get back a response that sort of provides some additional information about it, and potentially, maybe I've asked a question where, like, it doesn't know, it wasn't trained about AWS communities, so it has to go and try and find, like, what is an AWS community, and then try and derive, you know, the good things about that. And so then it might return a list of tools to go and do that, right? So we'll get a response and we'll get some tools. And so then the agent might go and invoke that tool and then get back a response. And then it might send that response, it'll send that response back to the large language model and it'll come back again, right? This is why it's a loop, right? It's an indeterminate loop. It could loop once, it could loop multiple times, depending on until the the model thinks it's got a good answer, and then the agent will then return that, right? So that loop could go multiple times. Like I could invoke a tool, that tool might respond with some information about, hey, you need to go and get this other information from this other tool. And so it will go through that loop multiple times. And through the auditing, you'll see through some auditing capabilities, you'll get the kind of like what's happening and like the decisions that it's making around invoking tools. You'll be able to kind of follow that. And then the agent will then gather all of that data and then return the response back to the client, right? So let's talk about like some of, I guess, the different ways we can deploy our agents. So we can have an agent that's running completely locally. An example of that would be, your Claude Code or your, Claude or ChatGPT. They're kind of, these are local agents, right? This is the agents running on your computer or in one environment, and it also has access to tools that are also running in your computer, right? And we'll see some examples of that. But the classic one is like you're using you've hooked up a couple of MCP servers to your agent, and it's running those tools locally, or it's using a tool that accesses, say, your file system or something like that, right? That's an example of that. So there's one example of like a deployment model. There's obviously sort of more, I guess, classical one would be, you have a client app that's running in your environment and invokes the agent via an API, right? So you're exposing an API, and then that goes and basically you're just passing the information through the API to the agent, and then the agent then calls and executes, and the tools are then basically local to the agent environment, right? So you might be, we'll see exactly what that kind of looks like with Strands, when you kind of do that within a sort of Strands environment, where the tools are just basically additional methods in the agent code that it has access to. So that's a very common, that's a very common model people are using it for. Good. Another one is where everything's kind of isolated, right? So we've got the client app, we've got our agent, and then our agent is actually calling tools remotely. And typically what that is as a remote tool would be something like you've given the agent access to an API that it's calling. And that tool is running somewhere else. So the agent is then just basically orchestrating a bunch of APIs or doing that through, let's say, model context protocol, or a tool is another agent that it's calling to go and do that work, right? So this is sort of the typical kind of distributed environment where you've got multiple agents running, and they're accessing each other sort of remotely. And it's kind of where they're running is kind of irrelevant as long as it can access it via the appropriate protocol. Another one is like this is kind of like, this is probably more like what happens when you are using like a local, with a local agent as well, but the idea of you can have the agent running in an environment, you've got hosted tools, so tools that are running elsewhere, but you also the agent might also provide a way to run local tools, right? So the tool basically sends back a request, the tool runs locally, and then that sends that back to the agent to kind of use that context, right? So think of that, you've got something, then it's asking, do you provide additional information, maybe that's, resources you have on your computer, and you only want to provide that at that time. You don't want it to have access to it all the time, right? So you would then have a way to say, yes, I accept this tool, it's going to run, it's going to access my file system, it's going to read some file, it's going to send that to the agent for context, right? This is probably becoming more and more the case for things where you only want to expose the data to the agent at the time when it's executing, and then not again, right? So you want to provide sort of limited scope access to certain data. This is a very common way that you can do that. One of the things that you think Strands was created by AWS, and you would think, oh, well, it's just like a front end to Bedrock models, right? This is one of the cool things that I really like about Strands, is that it's actually agnostic to model. So you can plug in whatever model you want. as long as it's like, usually most of them have sort of an open API kind of, sort of input or API where you can kind of integrate the model. So here's an example of creating a model that uses Ollama. So those that don't know, Ollama is like a framework where you can run LLMs locally. Basically, you create Ollama services, and you basically pulls a container and runs that on your machine, assuming you've got the resources to run the model, which most of us don't run GPU supercomputers as desktop machines, but more and more with like on newer Macs and things like that with unified memory, it's getting kind of like plausible to run certain models. Some of the newer models have like extremely light versions of that, which you can run locally. So it's kind of a thing, it's kind of cool. I'm hoping to get access to some hardware that will allow me to do this more and more. But the idea is that you could run the whole environment locally on your computer, or more often than not on some dedicated local device, right? So NVIDIA are launching these sort of AI kind of, sort of like the Intel NUC, but like a sort of GPU accelerated version of that. And so it sort of opens up the idea for experimentation and doing things. And so then you can still use the same tools, right? You're not having to then do something different because the model's locally, right? So it can run that and access that in the same way. So it's very easy to sell, like to use Strands, even if then you're calling like ChatGPT or Open APIs, or Mistral or any other model, you can kind of wire those up in here. And so the idea is that you might have an agent that you might deploy to AWS, but it might use OpenAI's model behind the scenes. And you just have to kind of configure that. So it's one of the things I really, really like about Strands. So I wanted to, one of the challenges before, around like building agents and really deploying them was, there was a lot of work you had to do, right? Like you had to create the agent, and then you had to deploy that. Typically, you would deploy that to something like ECS Fargate, for example. A lot of people tried to run them in Lambda. It's not really a great fit. We had this talk, for those that were in the talk before. ECS Fargate is a really great deployment model for running agents. But then you still had this problem of like, what if I just wanted an agent that like had like memory, like could remember the fact that I had a conversation with it. If you looked at the examples I provided before, they were all like one-shot examples, right? It invokes the model and gives you an answer, and then it's forgotten. Like you asked it, and the next thing, and it has no context. I did not remember anything. So that's not very useful. And so typically what you want to do is build some kind of memory or context, right? So persisted context. So with Strands, if you want to do that, you have to hook up like a memory solution. Like you can integrate that with like DynamoDB and other sort of solutions as well, S3 and things like that to store that history. But you had to kind of do all that work yourself, right? You had to kind of build that and wire that up yourself. And so like Amazon do well is they remove that complexity, right? They provide services that sort of hide that. And this fits into this serverless model, right? I think, Bedrock Core is exactly that. So it provides a consistent runtime environment with the ability to do like session isolation. So, individual agent core sessions are run individually for each agent. So basically what actually happens is behind the scenes, it's actually not running, it's a container. Like the deployment models, you deploy an ECR image. But instead of it being running on like Fargate or something like that, behind the scenes it's running using the same thing Lambda and actually Fargate do, which is Firecracker micro VMs. So behind the scenes for every session that gets created, that you interact with that agent through the Bedrock Agent Core runtime, it's spinning up a micro VM, right? So it's spinning up a Firecracker micro VM for every session. So you get that isolation, right? The same level of isolation that you get with Fargate and that you get with Lambda. Another thing that it provides like a set of like additional kind of resources that you can manage. So it also provides memory and context management, right? So they've sort of abstracted the way you might have had to go and build some memory management before, like in DynamoDB, which is, you know, earlier in the beginning of the year, that's what we were doing when we were building our agents internally at Base 2. We were doing that, right? We were kind of having to, you know, figure out how we were going to store this. With Agent Core, now that provides that as a capability, right? So we can just say, hey, cool, we'll hook up the Agent Core memory and context management, and we can kind of forget about it. The other thing it provides is like identity and access control. One of the advantages of the agent and Agent Core runtime is it's an AWS native solution, right? So identity and access is, so if I have an agent that's going out and reaching out to other AWS resources, you know, then I have identity and access management control, right? I can set IAM policies for the agents that are running, which is super, super powerful. Another feature of Agent Core is called Agent Core Gateway. And Gateway is really the ability to provide that access to like traditional APIs and exposing them as MCP resource or MCP servers. So you can take existing legacy APIs and very quickly wrap them up and do that. I don't actually think that's a very good idea because one-for-one mapping for MCP to APIs is not really what it was intended for, but if you needed to quickly provide some access to an agent to some legacy APIs and you didn't want to kind of teach it how to like call those APIs, you can do that with the gateway. And also one of the key things is that it provides is that deep observability, and also the ability to do versions and things like that, agent versioning and stuff. So you can do you could do quick A/B testing and things like that. We've only got a couple of minutes left, so I was going to quickly try and drop into a demo to kind of just show you like some of the capabilities. I think hopefully these mics have switched. Second. If this actually responds. And end show. Right. So I might, so you can see, good, you can see that. Good. I'll make it bigger. Good. Right, so basically what I'm going to do is I'll just run a couple of demos. I'll just run this first one. Except I'm hovering over it. So basically this was the example code that I showed you. So I'm just going to run this. Right, so basically what I've now called the agent and I'm now basically passing that to, and it's come back with a response, right? As most LLMs do, they're very, very verbose. So it's providing a lot of information. But as I said before, this is it's a one-shot agent, right? It's done its thing, it's given me an answer. There's nothing there. What if I wanted to hook up a tool? So this is an example of a tool and how you would connect a tool in Strands. Right. So basically, what this code is doing. Let me start it because this one takes a little bit. Right, so what it's actually doing is, so Strands itself comes with like built-in tools. So it comes with a list of tools that it sort of provides. One of those is an HTTP request. And so basically when I construct my agent, I say, here's a list, I explicitly give it a list of tools that agent can use, right? In this case, it's the HTTP request. But if you notice in the prompt that I'm sending the agent, I didn't actually say to use that tool. But it figured out, based on what I gave it, and it said, oh, I've got some tools available to me, so I'll go and actually execute that tool. Right? So I didn't have to explicitly say, hey, go and use this tool. It went, I'll figure that out. And so now it's trying to go and do what it needs to do. Not that interesting what it's doing, but more the concept of how the tool's going. How would I provide in Strands, how would I build like a native Strands tool, right? So this example here does exactly that. Let me kill this one because you don't really care about the answer. Right. because we're here, so we didn't really need to know that. So let's go and look at this other one. So here in Python, I can just use a Python decorator to say, hey, this method is a tool, right? So this is a random number generator. It generates a number between the start and the end. And so when we run that, agent, and we can see we're just passing in the agent the same way. I've asked it to generate a random number between 1 and 10, so it's going to extract that number 1 and the number 10, and then feed that to that function. So it knows how to do that. And interesting enough, because I decorated the Python function with the type information, it knows how to extract and map that typing. I didn't have to do anything. If I didn't do that, it would have tried probably calling it as a string, probably got an error, and then tried again, like it tries to correct it when it doesn't work. And see, it generated a random number. What if I want to actually connect an MCP server? So connect to an MCP server. I create an MCP client. I specify what that client is. This is actually going to, when I run this, it's actually going, which I'll, so what it's actually going to do, if you watch very quickly, it actually went and pulled the package, that package, Python package down, and actually ran it. So this is one of those examples where, like, running MCP servers inside the agent, maybe not the, you really need to trust the code that you're calling, because I just downloaded some random code off the internet and ran it on my computer, right? So, you know, I had to trust that the Strands agent, so what I'm actually loading is actually the Strands agent MCP server itself, which is Strands, like, information on how to build Strands agents, right? So it's kind of a bit meta, but yeah, that's, and that's the question I asked, right? So, so I gave it the tool to go and find out how to basically, what is Strands, how to build Strands. So it goes and pulls, you can see it pulls the docs, it fetches the examples, and then returns a whole bunch of things on how to do that. The more interesting one is the agent-to-agent one. So Strands can also build agents that are part of that support the agent-to-agent protocol. So it is super easy to do. I can create a server. So I just basically create my agent as I would normally. I've got it hooked up to the calculator tool. And I have the ability here to create an agent server, and then I can just start it, right? So what this is going to do is going to start a Python server. So when I run this, it's basically going to start a Python server that's running my agent. It's listening, like, by default, it just listens on 9000, and the A2A protocol has, like, this, follows this kind of well-known location. So there's basically a well-known URL that we implement that basically is the agent card of the things that this agent can do. And so it returns that. So when I run the client, this one's still busily doing its Strands thing. AI demos aren't great for talks because they usually take very long. Like, not pre-recorded ones, live ones usually require a bit more. Right, so we'll run the client. And so basically what it's done, it's gone and contacted and if we look at the client code for it, basically we tell the agent that we have a A2A tool provider, and we give it the URL of our agent. And then we create our Strands agent as per normal, but we provided the list of tools that the provider provides. And then I gave it a very generic prompt. I said, pick an agent and make a sample call. I didn't actually say, like, what call. I said, figure out what the agent can do, and then go and call that agent with whatever you think would be appropriate, right? So that's kind of like, you can when you have like a network of agents, that's kind of like you can often leave it up to the agent to try and figure out what you do. The thing that is important that when you build an agent, that you provide very, very detailed information about the capabilities, right? Typically through descriptions for tools. So it's really funny, the code becomes less important. What becomes more important in this is like the documentation that lives around the code. That's part of that description. The metadata around your tool becomes super important. And in fact, I've actually started using AI tools to write those better. And so like the ability to say, because it's really good at generating lots and lots of text that it's more useful for a machine to read than a human, but that text is then can be fed in as a description. So that's super powerful. I'm going to just quickly switch back to the slides because I'm out of time. And quickly wrap up. Right, so I guess the key takeaways is Strands is really great because it's modular by design and really makes building agents super easy. Like we're building lots and lots of them now. It provides kind of the secure auditability. Obviously being AWS, it's sort of cloud native, but it's also standards first. So MCP for providing context and sort of agent to agent for collaboration. Like we're now running a whole heap of these in production on Agent Core. Agent Core is still in preview, but it's been super awesome. So thank you very much, and questions.
So we're gonna, thanks Aaron, appreciate that mate. We've probably got time for one very quick question, then we have to roll straight into the next session, sorry.
Did you use any other agent frameworks before you settled on this?
We used LangGraph before. And I mean, they're all, like a lot of those APIs they take a different approach, right? They come more from the model side and less from like buildings from a sort of thinking about an agent as a standalone thing. And so, yeah.
Thanks, Aaron. Appreciate it. We're gonna go straight into the next session now.